Welcome to this video training lesson on finding SQL injections. In this video, we will see how to manually test website parameters to find possible injection points. We will see how to detect injection points and reverse engineer query structures, both by exploiting SQL errors printed on the output page and by using blind detection techniques. For this video, we already configured our browser to use Burp Suite as proxy. The first application we are going to test is victim1.site. Please note that this is not a public website you can find on the internet. Let's add victim1.site to Burp Scope by copying its URL. Going to the Target tab, Scope, and then click on the Paste URL button. Moreover, we can go to the Sitemap tab and set a filter to display only items in scope. Another thing to do is configuring the spider. We switch to the Spider tab and configure it to prompt for guidance when submitting forms. For now, we disable the master interception. Victim1.site hosts an online procurement management web application. User input is used to display news details. And to log into the web app. We can start our testing with a news detail ID parameter. Let's append a single quote to the ID value. As you can see, a SQL error is reflected to the page title. To make sure that this parameter is vulnerable to SQL injection, we can try to craft a payload that makes the query work correctly. The query is probably something like, select title text from news where ID equals 26. If we send 26 single quotes semicolon and a SQL comment as payload, the query works correctly and gives us the same results as sending just 26. This confirms that we can inject SQL commands in the ID parameter and get control over the original query, thus, of the database. Another feature that accepts user-controlled input is the login form. First, we try to log in by sending A as username, B as password, and click the Login button. The credentials we provided are invalid. Now we try to inject a single quote in the username and leave the password field empty. The application prints on its output a SQL error. Please note how a piece of the original statement is reflected on the output. The error tells us that the query generates an MDS hash of the password and checks the result against the database. Let's try to use the information to test the password field. Testing password fields for injections via a web browser means not being able to use the characters we send in the payloads we craft. So we switch to Burp Suite and enable the master interception. Then we try to log in with A and B as username and password. The proxy intercepts the request. We can send it to the repeater by right-clicking on it and clicking on Send to Repeater. Let's switch to the Repeater tab and add a single quote to the password post parameter. Now we can click Go and see the results. The application triggers a SQL error. This means that the password field is also vulnerable to SQL injections. As you studied in this course, most modern web applications do not print errors on their output. This forces us to use other techniques to find injection points. Before moving to the next application to test, we drop the login request to Burp Proxy. Disable the master interception, switch to the browser, and open a connection to victim2.site. Victim2.site hosts a recording studio website. We add it to Burp Scope. While browsing the site, we discover that there are many features which use user input, like the theme color chooser. The album details page, and the login form. Let us test how they work. We can automate some of the attack surface mapping phase by using Burp Spider. We go to the Target tab, Sitemap tab, right-click on Victim2.site, and click on Spider this host. Burp Spider prompts us for guidance, as it needs to know how to treat a post request. The request has just one parameter with 4 possible values. We know from previous inspection that this parameter controls the website background, which users can choose. So we enable the Iterate checkbox and submit the form. The color chooser feature is available on all the website pages, so we ignore further requests to do it. Burp displays pages which accept users' input with a gear icon. The albumdetail.php page accepts ID as getParameter. To test it, we can use Burp Repeater. Let's right-click on the request body and choose Send to Repeater. We switch to the Repeater tab and send the request as is. As you can see, the web app retrieves the album title, the artist, and the album price. We create an auto-scroll action to make Burp automatically scroll to the section of the page containing the query results. Then we append a single quote to the ID value and submit the request. The response does not contain any data nor SQL errors. To test for SQL injections, we may have to try some payloads and reverse engineer the query structure. Let's start by creating an always true condition by writing single quote or single quote A, single quote equals single quote A. Please note that we have to URL encode the spaces. We send the request, and the web application outputs some album details. To confirm that the ID is vulnerable to SQL injections, we have to test it once more with an always false condition. ID is vulnerable. Note that ID isn't the only user-controlled parameter of the request. To conduct a proper penetration test, you have to test all the get, post, and headers values, looking for vulnerabilities. In this video, we will just test the ID parameter and the cookie header content. We clear out previous payload and start testing the cookie header. The cookie color parameter controls the page background color. If we set 1 as color parameter, the background will be white. If we send 2, the background will be yellow, and so on. We can use the same procedure we used before to test for SQL injections. Let's start our test by injecting an always true condition, 2 single quote and single quote A, single quote equals single quote A. It doesn't seem to work. We can replace single quotes with double quotes and see if we get to something. We're still unsuccessful. Probably the application developers were expecting only integer parameters to be passed by the cookie, so they chose to not use quotes at all. Let's try to inject 2 and single quote A single quote equals single quote A single quote. This returns a color. We seem to be on the right path. As we did before, we also test with a false condition. The false condition doesn't return any color back, so we can tell true statements from false statements. The cookie color parameter is vulnerable to SQL injections. Now we test the login form. Switching back to the Target, Sitemap tab, we can send the login post request to the repeater and start testing it. As we did before, we send the original request to the site to study the response. The login result is displayed in the body of the page. We did not successfully log in. Let's configure an auto-scroll rule, and then we try to inject some characters in the username and password fields, trying to break the SQL syntax. As you can see, the web application just displays a login failed message and does not display SQL errors. We have to inject some payload and transform the original query in a true-false condition. Let's start with the username field by injecting single quote, space, or space 1 equals 1 semicolon, space, minus minus space. Injecting the semicolon in the comment helps us to force the query to evaluate just an empty username and an always true condition. The injection doesn't work. In the first example, we have seen that the parentheses can be used around SQL parameters. Let's try to add a closing parentheses and submit the request. The website changes and prompts us with a welcome message. If we change the always true condition into an always false condition, we get a login failed message. Username is vulnerable to SQL injections. We can stop our testing here, but remember that in a real penetration test, we should have tested all the parameters, and we also should have performed a thorough manual investigation of the web application. The information gathering and attack surface mapping phases are extremely important when hunting for vulnerabilities. This concludes this video on finding SQL injections. Thanks very much for joining us.